All right, hey calculus, so we're moving on. We're into solving differential equations now and looking at what are slope fields. So the good thing is solving differential equations is a continuation of what you've been doing in terms of integration. So we'll start with this problem here. Example 1, we know that y prime is x squared minus 2, and we want to find the general solution. That means we want to find what's the y equals, right? What's the y equals equation? What's the original function, right? So we've done a little bit of this in earlier in chapter 4 when we were dealing with integration. We've done some of that. So what's going to be the process? Well, I can't integrate unless I have a dy or a dx. So the first thing I'm going to do is I'm going to change y prime to dy or dx. Okay. I'm then going to go ahead and multiply dx to the other side to get my differential equation like this. Okay? So on every problem, you want to get to this point where you have the y's and dy on one side, the x's and dx on the other. No, obviously there's no y's with the dy, but there could be. There's basically a 1 with that. Okay? So then once we get to this part, we're going to then integrate each side. So I'm going to integrate the left, I'm going to integrate the right, so that I can work backwards and try to get the original equation. So the integral of 1 with respect to y is just y. The integral of x squared minus 2 is x cubed over 3 minus 2x plus some constant c. Right? Because that's our constant of integration. We put that at the end, and this is our general solution. Okay? So what I want you to also kind of get from this is there's a mention of what's a slope field. There's the term slope field. So what does that refer to? Well, before we even got going with this, we could have at least use the original problem to get an idea of what our graph is going to look like. What I mean by that is, remember derivative, here we know y prime equals x squared minus 2. Well, that's telling us the slope of the graph. So one thing I could do, and I'm just going to I may go to -3 here. Go no more than this. All right. So let's just say we put the axis, our coordinate plane there, and we know that this tells us the slope, right? It tells us the slope. It says, okay, your slope is x squared minus 2. So if I go over here where x is 1, and I plug in a 1, so this is in terms of x. So if we do y prime of 1, we get 1 squared minus 2, which is -1. So we know that the slope has to be -1 when x is 1. So what we're going to do is we're going to go to where x is 1, and we're going to make all these points. And we're going to do our best, and we're going to draw a slope of -1 like this. So again, this is me making a slope field, and I'll show you how this ties into that over there. All right. I'm going to continue this for each of our x's. So I'm going to do x is 2, x is 3, then I'll work my way backwards. So y prime of 2, we get 2 squared minus 2, we get 2. So I'm going to draw a slope of 2 there at each of these where x is 2. So 2 is going to be like that. That could be the slope there. This is going to tie into why there's a plus c here, right? Why do we have a plus c on that? And I'll tie this in. We're going to then do y prime of 3. We get 3 squared minus 2, which is 7. So that's a pretty steep slope. So on all these here, make like a slope of 7. All right. Y prime of 0, we get 0 squared minus 2, which is -2. So maybe like this. So when all the x is 0, we're going to draw the slope there of -2. Okay? All right. And we'll do -1. So do this one. So y prime of -1. You get -1 squared minus 2, which is -1. So at -1, we're going to draw at all these x's, we're going to draw a slope that we think is close to -1. We can just go to 2 here, -2 and stop. So we get -2 squared minus 2, which is back to 2. So we're going to draw a slope of 2. The best I can. So now, you're looking at this, you're like, well, what does this stand for? Well, basically what this is showing us, if I take a different color, say we take the pink here, then maybe our graph, if I can do this the best that I can, maybe our graph does something like this. All right? You started to see that cubic shape. But it could also be here. And this is where the plus C comes in. Because think at the end, plus C is a vertical shift on a graph. So we don't know whether it's this one or it's this one, or it also could be here, and so on. And that's kind of what the slope field represents. The slope field represents the slopes to the graph of the original graph, right? So would you agree that this shape here looks like it could go with a cubic graph there? And I think we would all agree on that. So that's the purpose of the slope field, is it gives us an idea of the shape of the original graph, okay? We are able to find the original graph here, and this is what a slope field is. So all I'm doing with a slope field is once I get the slopes, so like I did on this one, when x is 1, I figured out the slope was -1. And at all the spots where x is 1, I draw just like a little segment, that would represent a tangent line there with a slope of -1. And I continued and did that. So sometimes we'll just be asked to make the slope field. Other times we'll be asked to solve the differential equation. So one more problem, I'm gonna do both. We're gonna do the slope field and then we'll solve the differential equation. We'll do a couple more of these, okay? So I'll move to the side. You can see the entire picture there. All right. So all right, so let's look at this one. So we're going to find the general solution. And we'll call this example 2. And our function will be, we'll say y prime equals x over y. Okay, so let's go through our steps. Again, how do we solve? How do we go through this? Well, remember, we're going to change this y prime to dy over dx. All right? So that's our first step. Make sure, so if we want to kind of list our steps here when we're solving differential equations, and I will call this, we're basically trying to separate our variables. So separation of variables, where we get x's on one side and dx and y's on the other, okay? So first thing, we're going to change y prime into dy over dx. That's it. That's the first thing. Then I'm going to cross multiply to get y's with dy and x's with dx. Okay? So if I cross multiply, y goes up, dx goes there, I get y dy equals x dx. Okay? Okay. And then I'm going to integrate so that I can get to integrate to get to original function. Okay. All right, so now we're going to integrate this. So let's see. So if I integrate, I got to integrate both, the left and the right. Since the left has a y with it, I still have to do that. So what's the integral of y with respect to y? We would say y squared over 2. What's the integral of x with respect to x? We're going to say x squared over 2 plus some constant. I'm going to call it C1 because it could change as I go to solve. So notice, right now I have y squared over 2, but I want to get the original function, which is going to be a y. So what I'll do is I'm going to multiply everything by 2. And those 2's will cancel. And so now I get y squared equals x squared plus 2 times some constant, which I can now change into just a plus c. And then to get y plus or minus the square root of x squared plus c. Okay? All right. Now that won't be a function. If I have both of those, I would have to see which one we would keep depending on whatever point we were given. So anyways, that's the process of, we're going to get the variables separated, and then we're going to integrate, and then the last part is solving for y. So that's solving the differential equation. Okay, there's that. What does this graph look like? Well, maybe we're not sure, right? But if we do the slope field, we could get a good, maybe a good idea. So we're going to also do the slope field for this function. Okay. So make sure it's showing up there. So we'll just do -1, -2, 1, 2, 1, 2, -1, -2. Now we're going to plug in our dy over dx is x over y. So this is what we're going to plug in now. So for instance, when I'll do x is 1 first. So I have 1, 2, 3, 4, 5 points. So for instance, this is the point 1, 2, which means I'm going to plug a 1 in for x and a 2 in for y. So if I want to get the slope at the point 1, 2, well, x is 1, y is 2, I get a half. So now I got to make a little line segment of a slope of a half. 1, 1 right here, right? So x is 1, y is 1. We get 1 over 1, which is 1. So now I get a little bit of a steeper line. Okay, 1, 0. So dy over dx at 1, 0. That's going to be 1 over 0. That's undefined. I can't make a slope. 1, -1, I'm going to get a slope of -1. 1, -2, a slope of -1/2. So I'm going to go through and calculate and put all those in. dy over dx at 1, 1. So dy over dx at 1 and -1 would be 1 over -1, which is -1, and so on. And then you're going to go and complete this. So here I can see this is 2, 2, so that slope is going to be 1, like that. 2, 1, so that slope is 2. 2, 0, don't have 1. 2, -1, that slope is -2. 2, -2, that slope is -1. All right, 0. On all these, since x is 0, the slope is going to be 0, like that. All right, -1, 2, so that's -1/2. -1, 1, that's -1. -1, 0, we can't do. -1 over -1 is 1. -1 over -2 is 1/2. So you're starting to see where we can get an indication of maybe what the graph is gonna look like, what it's gonna do a little bit, and so that's helpful there, and it helps us to see that. Oh, we can't do 0 with 0. Okay, and now we're generating the slope field. Okay, all right. One more. Obviously, it can become difficult in solving some of those. So, you know, this is a good review of your integral rules. Then again, now isolating, and we'll call this part 1 of solving. I'll give you easier problems to work, and then we'll do another video on more difficult. Let's do now where we're just doing a slope field, just a slope field, and we'll come up with what we think is the graph. So our slope field is going to be, we're going to make a slope field now. All right. So here's, we're going to do the same. And here's our graph. dy over dx equals 2x plus y. Okay. And we'll call this example 3. Make the slope field. All right. All right, we're going to do that, and then I'll give you a point that we're going to estimate if we think we have the solution there. So let's see. So we'll start, you can go left to right if you want. So you can see there's 5 points on each one here that we're going to deal with. We're going to find the slopes. So I'm going to pick one from each column. So we'll pick this one, we'll pick this one, we'll pick this one, we'll pick this one, and pick this point. I want to make sure that you can calculate these. So right here, this is the point, -2, 1. I'm going to substitute that in. So I can see that dy over dx is 2 times -2 plus 1, which is -3. So I'm going to draw my best a slope of -3. Okay? All right. We'll do the next one, -1, 2. Now you've got to fill out all of those. And I got 0 there. Okay? And what do we got next? 0, -1, so dy over dx is 2 times 0 plus a -1, we get -1. It's there. The next one's at 1, 0. 2 times 1 plus 0 is 2. Draw this. And then do the last one, dy over dx at, I think, 2, -2. So 2 times 2 plus a -2, we get 2. All right. So if you want to pause it and finish this, you can. I'm going to go ahead and graph all the little line segments there, and then we're going to approximate maybe one of the graphs, what we think the graph is to that original function. So let's see, so -2, 1. So that's about what your slope field should look like there. And let's just say that we know that the original graph goes through the point 1, 1. Well, if we know that, then we've got to make sure that we draw something that goes through 1, 1 and do our best here. You know, it's going to go like this. It's going to come down here and maybe could go like this, like that. Okay, just get an idea of the shape there. Okay, well, it can't go like that. That's not going to work. There we go. That's better. Okay, and that gives us the idea. So now we've drawn what we think maybe is the solution curve by doing that. So all I'm trying to do is draw something that fits along those line segments. Okay, so this will get you started. So your homework's going to be making some slope fields and solving some basic differential equations by separating the variables. All right, hope this helps, and this will be the end of part 1, and then we'll do part 2 next time.